In this video, we are going to go through the Boogeyman Capstone Challenge that is a part of the SOC Level 1 Capstone Challenges in the SOC Level 1 pathway of TryHackMe. And this one specifically, I believe, has to do with a phishing campaign. The last one that we did had to do with a series of network attacks that somebody did, and they were able to get past certain filters to get into the actual network, and they impersonated a user, then they escalated their privileges, and then they took action on their steps, so on and so forth. So that was a really good one. It was actually a really strong video. I liked it a lot, and I think this is going to be a good one as well. Anything that's essentially ranked medium inside of TryHackMe, I know is going to be a good test of everything that we've learned so far, so that we can go ahead and accomplish whatever the investigation is without too much help, and we are left to our own vices, essentially. So that's what we're going to be doing in this video with the Boogeyman Challenge, the Certified Boogeyman Challenge. I always get reminded of the Kendrick line, Certified Boogeyman. So that is what we're going to be talking about today. This is the outline, so just the introduction, the email analysis of looking at the headers, and then looking to make sure that the attachment apparently is an invoice or not. And then they got us, call the bank immediately. This is assuming that we've actually been hacked, and we're analyzing the network traffic to try to find the packets and the flow of the traffic that implies that we were officially hacked by the Boogeyman. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Boogeyman exercise. I do wonder whether or not this is actually something that exists out in the real world, or if it was just something that was created for this specific exercise. But the whole point of this is that we're going to analyze the tactics, techniques, and procedures executed by a threat group from obtaining initial access until achieving its objective. So there's a threat group, also known as an APT, an Advanced Persistent Threat. And those are very common inside of the MITRE ATT&CK framework, or the MITRE ATT&CK matrix. And the tactics, techniques, and procedures is also something that gets outlined a lot inside of the MITRE ATT&CK website. So these things are very common in the real world. I just wonder if the Boogeyman is real. I mean, everybody probably wonders if the Boogeyman is real. So let's go and look at the MITRE ATT&CK website and see if there is indeed something called the Boogeyman. So we are here, and we're just going to search for Boogeyman. That would be so interesting. There is no results. Obviously, there's no results. It would be kind of corny, I feel like. It's like kind of cliche if a hacker calls themselves the Boogeyman. It's like, really, dude? Like, really? But anyway, that's who we're dealing with today. And that's what he looks like, apparently. And he's trying to get into the financial office, the finance office. The prerequisites are that we need to know the basics of phishing and phishing analysis tools. And of course, Windows event logs, Wireshark traffic analysis, and T-Shark, which is the command line equivalent of Wireshark. For the most part, it actually has a lot of the functionalities that Wireshark does, with a few limitations, but you can essentially use T-Shark in the command line to quickly analyze traffic inside of a PCAP file, or even capture traffic if you wanted to. So very, very powerful series of tools that we have here. And there are a series of videos that were done for phishing that are on this channel that, if you don't know the basics of analyzing phishing emails and looking at email headers, etc., I would recommend going through those videos just so you can get a good crash course, so to speak, and all the fundamentals before we jump into this room. Because for the most part, they're not going to tell us where we're going to find things. They'll tell us, specific commands maybe that we need to run to get a report, but they're not going to tell us how to find the information and where the information would be located. All of that stuff we're left to our own biases to figure out on our own. The investigation platform is the virtual machine that I've already started, and it's on this window right here. So that's our virtual machine provided to us by TryHackMe. And this is another one of the reasons why I love TryHackMe. They even stopped their referral program, but I just can't stop singing their praises because it's a controlled environment. You can essentially run virtual machines and attack boxes and attack as many different virtual machines as you want without getting a felony on your record and getting arrested. So that's all amazing stuff. So we have the machine that's already loaded. The artifacts are the copy of the phishing email, which is dump.eml, PowerShell logs from Julianne's workstation, PowerShell.json, and the packet capture, also known as capture.pcap. And the PowerShell JSON file contains JSON formatted PowerShell logs extracted from the original EVTX file via the EVTX to JSON tool. And this is what we were dealing with in the last video as well. We had to convert EVTX files into CSV as well as XML files to be able to analyze them. All of this stuff is going to be included in the desktop artifacts directory, which is what we have right here. And we need to, this is the full path of it when we actually go into the command line. And that's easy to navigate. The tools will be the Thunderbird email email client. That's the word I'm looking for. So the Thunderbird email client, the LNK parse, which is a Python package for forensics of a binary file with LNK extension, Wireshark, T-Shark, and of course JQ, which is something that is used to process JSON in the command line. And these are some of the commands that we're going to need to get really good at. So grep is to search, awk and sed are also for search, and base64 is for encoding and decoding of various tools. I'll run everything inside of the command line, but there's a really easy way to decode something for base64 and encode something in base64, and really a lot of other encodings as well. And that is the CyberChef tool. And most likely I will probably kind of default to CyberChef. I do want to learn or get better at running these things inside the command line, especially if you don't have access to CyberChef inside of whatever environment you'd be running in. So it's always really good to learn how to do these things without CyberChef. But CyberChef is one of the best tools that you will get because you can do things like, you know, to base64 from base64, to hex from hex, and all of these things. And these are just like the common ones. There are literally, I would say hundreds of different operations that you can run, and they're categorized exclusively to do a bunch of different stuff for you. You can extract data using any of the extractors. So if you have a really large file or a really large block of text that you want to extract data, excuse the dogs in the background. If you have a big block of text or a big file that you want to extract data from, you can use the extractors. So again, really, really powerful tool, and I would highly recommend you check it out if you have not used it already. So that being said, we have covered all of our bases, and now we can jump into the headers portion. Here's the scenario. Julianne, the finance employee working for Quick Logistics LLC, received a follow-up email regarding an unpaid invoice from their business partner, B Packaging. Unbeknownst to her, the attached document was malicious and compromised her workstation. This is the email. So, hope you're well, blah, 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 blah. You may use this code to view the encrypted file. And best regards, Arthur Griffin. And then there's something else that's also missing at the bottom. So there's two things that have been blacked out for us. The respective document number, the invoice number is probably this. The payment is for January 2023. And that's essentially it. So the security team was able to flag the suspicious execution of the attachment in addition to the phishing reports that were received from other financial department employees, making it seem like that it's a target attack on the finance team. And upon checking the latest trends, the initial TTP, the tactic technique procedure, used for the attachment is attributed to the new threat group named Boogeyman. And we already verified that they actually don't exist inside of MITRE, so they probably don't exist. Known for targeting the logistics sector, and we need to analyze and assess the impact of that compromise. So this is the investigation guide. This is essentially the outline that we need to take to be able to analyze this thing. So given the initial information, we know that the compromise started with a phishing email. So let's start with analyzing the dump EML file located in the artifacts directory. There are two ways to analyze the headers and rebuild the attachment. The manual way is to use command line tools like cat, grep, base64, and sed, and analyze the contents manually and build the attachment by decoding the string that's located at the bottom of the file. And so this is what it looks like, right? So essentially you cat whatever the file is, and then you base64 decode whatever the contents are into the zip file that we have over here. Okay, so the echo portion right here, it says it's a sample command to rebuild the payload, presuming the encoded payload is written in another file without all the line terminators. So the alternative and easier way to do this is to double click the email file, open it on Thunderbird, and the attachment will be saved and extracted accordingly. Once the payload from the encrypted file is extracted, use the link parse to extract the information inside the payload, and that would be link parse, and then we give it the LNK file. So let's go and actually analyze this to be able to pull the information that we need to answer some of these questions. So easy money, and because it is a singular file. So in the, not the last video, I think it was the video prior to the last video, where we start looking at another phishing campaign that we had, and I created a script inside of that video to analyze a bunch of EML files, because in that video we had, I think, 5 EML files, and you can still manually look at 5 EML files. It's not that many, but if you have a large list of employees, let's say 500, if you have 500 EML files from all of their email accounts that you need to analyze, at that point you need to start using scripting. And so I created the script that I'm not going to recreate here because we only have one EML file to deal with. So that script, and it's not the last video because the last video was not that investigation, is, I would say, it's the video previous to the last video. So if you actually go to the uploads on this channel and look at the date range, essentially, it's not the one that you're watching, obviously, not the one prior to this one, it's the one prior to that one. And I guess I could go ahead and find it real quick. So let me just go and find it real quick. So here's the channel. We come to videos real quick, and then we are looking at the latest tab, right? So in the latest tab, we have Catch a Hacker and then Phishing. And this is the one. So this is the one where we create the shell script that will analyze multiple EML files, and then through those EML files we extract the data that we need. And it's a very useful script. I think a lot of people will get a lot of value out of it. So I would highly recommend you go check it out, especially if you are going to be in incident response or security analysis or digital forensics or anything like that, and you're going to be analyzing very many files, because it's not necessarily just EML files that you'll end up analyzing. You'll probably end up analyzing a bunch of different types of files, and it's always good to know that. And another way that you can also learn about scripting is to obviously go to the Linux Plus playlist that we have on the channel. And on this playlist, the last video, the 5th video, is all about scripting, and you'll get a chance to learn how to create a variety of different shell scripts for automation, to parse through documents, and to learn a bunch of different types of information about the data inside of that document. And then there is one other video that I do want to point you to real quick, and that video is going to be the Python for cybersecurity video, and that one I have to actually kind of search because I know it's a little bit further. So if we look for Python for cybersecurity, it's this video. So it says build Python algorithms for cybersecurity, Python for tutorial, or Python tutorial. And this one is a really robust video. This video is what, 6 hours long, 6 hours and 17 minutes long. And it starts from the very basics, where you actually learn how to, download Python, run your very first program, go through all of that, and then by the end of it you will learn how to build an algorithm. So you get all of the foundations and the fundamentals for Python, and then from there you'll get the advanced stuff where you can actually read from a file and parse data from a file and extract and manipulate the data from a file and create an algorithm for cybersecurity. So a lot of great tools, a lot of great videos available on this channel to really think about it. Honestly, it's a little bit over a year, maybe like a year and 2 months or something, that we've had this channel, and I've had over 300 videos that have been uploaded on this channel, and it's pretty interesting what has happened. And I'm kind of digressing and I'm going on a tangent, but there's a lot of stuff on this channel that you can use for your learning pleasures. And if you're interested in a specific topic, you can either go and look at the playlists that are available, because we do have a lot of good playlists. And then there's also the search function over here where you can actually search for a given topic. And if you find it, great. If not, drop a comment and let me know that you are interested in it, and I will see if it's possible to create it for you. Now, all of that out of the way, we are now going to actually analyze this very first artifact, which is going to be our EML file, which is the dump EML file that we have over here. So I'm just going to double click it. It'll open up inside of, oh no, actually, you know what? Interesting. It just opened up like this. So we can actually see the email right here, right? So this is the, I think it says the first question was who is the email used, what is it? Who's the email address used to send the phishing email, or excuse me, what is the email address used to send the phishing email? And it will be A Griffin. So that's that. What is the email address of the victim? And that's also here, which is Julianne West. And we didn't even have to open this inside of Thunderbird yet. So there's Julianne Westcott. And then what is the name of the third-party mail relay service used by the attacker based on the DKIM signature and the list unsubscribe headers? So now this is where we actually need to go ahead and see some data from the headers of this thing. So we need to actually look at the email headers. And to be able to do that, let me see if I can just open it with Thunderbird. Boom, there we go. So open with Thunderbird, and we're going to be able to look at the source code of the email, or at least the headers of the email. And then you just search for the, what is it, the DKIM signature and the list unsubscribe headers. And from there, we'll be able to find the third-party mail relay service. And then what is the name of the file inside of the encrypted attachment? And so the name of the file inside of the encrypted, I want to say it's invoice.zip. No, it's not, because we need to actually unzip it. So I would need to download that file. So let me just write down here, we see invoice.zip. So we're going to save it. And then it's going to be saved. I'll save it onto the desktop inside of the artifacts. So we'll do that. And we'll save the zip file inside of our artifacts. And there it is. And then we'll extract that in a quick second. And then what else do we need? What is the password of the encrypted attachment? Based on the result of the link parse tool, what is the encoded payload found in the command line argument field? And that is it. So let's see. We need a password. We need the password is this right here. So invoice 2023. So there is that. See, and that makes it like really legitimate, because if they're giving you a password to access it and it's an encrypted file, you're like, oh, okay, so this must be legitimate, because it seems to be a very sensitive document, and they're giving me a password to unlock this document and all that. So it's a really good way to, they call it pretexting, and pretexting is essentially a strategy in social engineering, and we talk about this in great depth inside of the Security Plus playlist that's on the channel. But the pretexting concept is to like manufacture this story inside of the mind of your target to kind of make them believe that this phishing campaign is real, right? Or it's not a phishing campaign, right? Like that it's actually a real email that's being sent. And usually it's things like this, like little tactics like this, where it's like, hey, you know, we have this invoice that we need you to check out. It's encrypted for privacy reasons. Here's the password to be able to access the file. And it's like, okay, all right, it sounds legit. It sounds super legit. And it's something that will make a person kind of drop their guard a little bit. So anyways, DKIM and list unsubscribe headers. So let's zoom in here a little bit. What's going on? Why can't I zoom in? Okay, here we go. Zoom in. All right, so there's a few different ways that we can access this information. So usually if you go to view, you'll be able to just look at headers, and typically it's just the normal headers, which is what you see right up here. And then if you go to view and then do headers and do all headers, what it does is it gives you all of the headers up here, and it's a kind of difficult to search through this. So what I like doing is I just like opening the headers inside of a separate document. So I'm going to go back to normal, just kind of collapse that. And what you can do is you can look at message source. And when you look at message source, it just opens up the whole thing for you. And this is all of the information inside of it, including the encoded portion. So these are the things that you see right here, like the stuff that end with equal signs. These things right here, these are all encoded elements of this document. So base 64 encoding is what we're talking about. So like this full thing, I would assume is like a full base 64 encoded element of this document. So real quick, just to kind of display, let's see, maybe we'll even find something information. Why can't I highlight this? This is like obnoxious right now. So if we copy that, there we go, and then we go to CyberChef and drop that over here, and then it has an actual magic detection right here, so we can just do that, and then now it gives you the decoded version of all of that jargon, and it's a PK zip file. Extension is B64 application octet stream. That's basically what this whole block of text actually equates to. So we have the attachment invoice zip, the encoding is base 64, etc., etc. So the big thing that we're looking for is the DKIM signature, right? So that's the one thing, and then the list unsubscribe, because we want to find that forwarding email service. So the reason why I open it up inside of a text editor like this is that you can actually now do Control F, and you can look for something inside of this document. So I can do DKIM, and then DKIM pass, and what is it? DKIM signature is what I'm looking for. So DKIM signature, there we go. So inside of the DKIM signature, we have, let's see what data might actually stand out here. So there are two emails, right? So there's, or two domains, technically, I should say. There's the B packaging, that's misspelled. If you actually look at it, K comes before seeing this. So that's actually misspelled. That's how they really psyched out the person who was reading this, because the website of the legitimate company is probably B packaging, but it's CK instead of KC. And a lot of times you don't catch something as simple as this little switch in the thing. So that would be the email that they're trying to impersonate. I would say this is the actual email that is being forwarded to, and this is also a part of DKIM signature. So there's two of them. There's two DKIM signature headers, elastic email, there's the elastic email that's revealed in one, and then the other one was the list unsubscribe tag that we can just go also look at. So if I do list unsubscribe, it will show me, this one right here specifically, and the value of this is also encoded, as we can see. And then let me see if there's another value. There's another value right here. Whoops, I skipped through it. So packaging, I think this was the original one. So let's go back one. And this is the other one right here. Julianne Wiscott, this list unsubscribe. And inside of this information, can we see that email domain? Let me see. So the only thing that I can actually see under the list unsubscribe is the multiple references to the A Griffin at B Packaging XYZ. So this, it feels like this would be the reply to email, not the forward email. And the question that they're asking specifically is the third-party mail relay service. And I would say that that is indeed that initial domain that we found. So let me go ahead and do the DKIM signature one more time, and I'm doing DKIM signature. And so that was the one that we found over here, where it has the elasticemail.com. I think that's it. So it's either elasticemail.com or it's B packaging misspelled. So I'm gonna do elastic email, and that is the answer. Okay, great. So elastic email is the third-party mail relay service. So there we go. Now, what is the name of the file that's inside the encrypted attachment? And in order for us to be able to do that, we need to unzip this invoice. So what I'm going to do is I'm just going to open up a terminal inside of this specific path. And that's one of the easier ways to just be inside of the path that you need to analyze the document. So you can just right-click inside of the artifacts folder or wherever you are when you're looking at the file explorer inside of Linux, or really any other service as well, like or Microsoft or Mac OS. If you just right click inside of any location, you can just open up a terminal in that location. Usually if you open up the terminal, it's going to be in this location, which is the root folder that shows everything that you have here, and then you would have to go into the desktop artifact by CDing into it, and that's not hard to do either, so it's not really that big of a deal. So anyway, so there's our zip file in red right there. So let's zoom in a little bit more for you. And so now what we need to do is we need to unzip it. So the command is unzip, and then you do invoice.zip, press enter. It's going to ask you for a password. And it was invoice 2023 with an exclamation at the end. And there we go. So inflating invoice 2023.lnk. And so that is the name of the attachment. So we're just going to drop that in here. And there's that. And the password to be able to look at it was that. And based on the result of the link parse tool, what is the encoded payload found in the command line arguments field? And so that's what we're going to be running our little link parse command right here. So lnk parse, basically. lnk parse. So just like this, we're going to zoom in here again. We're going to do ls. And now we have this lnk file right here. And so we're going to lnk parse and then give it invoice underscore, press tab. It'll fill it in for us. Press enter, and it's going to work like a charm. And we are looking for a specific field, which is the, which field? The command line arguments field. So let's go find the command line arguments, which is right here. And so we have the, what do we have? We have NOP, window style hidden, and then the encoding is this piece right here, and then the icon location. And what they want is, what is the encoded payload that's found in that? I'm guessing they want the actual encoded base64 payload, which is basically this whole thing. So we would need to highlight this entire payload, and that is the encoded payload. So can I copy that? There we go. We can copy that. I would assume that that's what they want. And let's see if that is, yeah, that is indeed what they want. So now we're going to just go, because we're nosy, we're going to go and drop it into CyberChef. And so what do we see? We see unknown file type. Have you tried checking the entropy of this data to determine whether it might be encrypted or compressed? And it doesn't really seem, I don't know, at first glance, maybe it is useful information or something, but for now, it does not seem like it would be any useful information. So moving on to, are you sure that's an invoice? This is what we found so far. So we know that there's a PowerShell command that was executed on the workstation, and we know that decoding the payload reveals the starting point of the endpoint activities. And now what we need to do is we need to analyze the PowerShell logs to uncover the potential impact of the attack. So we can start the analysis by searching the execution of the initial payload in the PowerShell logs, and searching the, since the given data in the JSON file can parse in CLI using the JQ command. We note that some logs are redundant and don't contain any critical information, so we can ignore them. Just like looking at something like this, I feel like the unknown file type, whatever BS, I don't know if that's relevant. Honestly, it might be, but it doesn't seem like it would be. If you've never used JQ, I've actually never used JQ, so it's nice that there's a cheat sheet here. It's a lightweight, flexible command line JSON processor, and it can be used in conjunction with other text processing commands, meaning grep, for example, or cat, or something like that. So we can use this as a guide to parse the JSON into beautified output, print all values from a specific field without printing the actual field, print all values from a specific field, I guess with printing the actual field, print values from multiple fields, sort logs based on their timestamp, and sort logs based on their timestamp, and print multiple field values. So there's also the full documentation that's available on the GitHub repo for these people right here, and it gets forwarded to the jqlang.org website, but originally it started as a GitHub domain, and then it just forwarded us here. And so we have the manual, etc., and the various commands that you can run, and you can navigate through the table of contents on the left hand side. So I will keep that open just in case. We'll move it towards the back. And what are the domains used by the attacker for file hosting and C2? Provide the domains in alphabetical order. What is the name of the enumeration tool that was downloaded by the attacker? What is the file that was accessed by the attacker using the downloaded SQ3exe binary? Provide the full file path. What is the software that was used in what is the software that uses the file in question 3? What is the name of the exfiltrated file? What type of file uses the KDBX file extension? What is the encoding used during the exfiltration attempt of the sensitive file? What is the tool used for exfiltration? So good amount of stuff that this person has done, and apparently he was successful, because if he actually used the tool for exfiltration, that means he got the data that he was initially looking for. So that is no good. And I mean, obviously there's also this thing at the bottom right here where it says they got us, call the bank immediately. So they did more than just export some files, exfiltrate some files. So all right, first and foremost, we need to look at the PowerShell JSON file, and we need to use this wonderful tool in the beautified output so we can see what the hell is going on. And first and foremost, we need to find second most, I guess, after we parse it, we need to find the domains that they used for hosting and C2 and do it in alphabetical order. So let's go over here. We are now in this location. Let me kind of zoom in a little bit on the terminal, and I'll drag the terminal a little bit to the right. Okay, perfect. So here we go. Let's clear this. Let's look at that. Where's the JSON, PowerShell JSON? There we go. So we're going to do cat PowerShell.json and then just pipe it into the JQ like that. And then it'll give us the beautified version of this, basically saying that it's organized, right? So this is usually what it looks like if you open up a JSON file inside of coding software or inside of a web browser. It's typically beautified like this, so it's useful, it's nice to see. So we are looking for domain names. Now the interesting portion of this is that domain names specifically may have a .com, they could have a .net or .xyz, whatever it may be. So it may be a lot. So let's see how big this file is over here first and foremost, because there's a lot of stuff that's inside this file. As you can see, it's barely moving, and there's a lot that's going on. So we need to find a way to sort through this a little bit better, and that would make our lives probably a little bit easier. We need to see, so what do we get? We could do print all the values, print values from multiple fields, timestamp, etc. So let's say from one field, if I want to print a value from one field, what would that be? Okay, so here's what we did. I'm going to start from the very, very first command that you already saw. So you saw me essentially pull the information from the entire JSON file, which is what this looks like right here. The very next thing that I did was I just wanted to see maybe if I only look at the script block text portion of it, maybe it'll find me some information that might be interesting. And then when I did do that, it did find me stuff that was interesting, but again, it was still too much output. There's just too many things that are going on, and then to be able to try to manually sift and sort through this is going to take literally forever. So I was like, okay, well, I'm not going to do that. So the next thing that I did was I created my very first grep command using regular expressions to try to find a domain name or a given domain name, anything that might even resemble a domain name. And so the first portion of this is what you see down here, cat PowerShell JSON, and then we did JQ, and then there's an option inside of JQ, which is the -r, and then pipe strings, and then you put the pipe strings inside of quotations or singular quotes, and the -r turns the output into raw data format, so it's not being formatted in any kind of way to make it look pretty or anything like this. We actually just want to get the raw data, and from the raw data we're trying to pull all of the string values, and then from those string values we're going to grep inside of this for the regular expression that would potentially yield us some kind of a domain name. And so if you don't recognize regular expressions, I understand it's not, I'm not here to explain regular expressions to you. There's an entire regular expressions video that's available on this channel. Very, very powerful stuff, and I highly recommend you go through it because it's a very powerful resource. It's like a powerful skill set to be able to create these patterns. And this is a really basic pattern, especially when you understand regular expression. So we're looking for lowercase a to z, uppercase a to z, and the numbers 0 to 9. And then you have a literal dot. And then you have, again, lowercase a to z, uppercase a to z. And then we want to say essentially from 2 spaces or 2 characters and onward. So show me anything that is greater than 2 characters, which could be a .io, it could be a .co, .us, it could be .net, .com, .xyz, etc. So when we run this, we actually get a good amount of data. Now, if we get past this exception portion and all these things, we can see that it's actually pulling a bunch of other types of data for us. So if I keep scrolling in a little bit, and I'm doing this slowly because I don't want to like pass it, but essentially what happens, oops, there we go. And essentially what happens is that you start seeing the domain name. So files.bpackaging.xyz, and that would be the file that would be one of the domains that we would be looking for, because more often than not, I mean, if it's especially the misspelled bpackaging.xyz, it's like, oh, okay, that's probably the domain for this thing. And the question asked us, what is the domain that they're using to the domains used for file hosting and the C2. Provide the domains in alphabetical order, and I know that we have 2. We have 2 domains that we need to look for, and that is one of them. I want to say for sure it's going to be the files.bpackaging.xyz. So instead of manually kind of like sifting and sorting through the rest of these outputs, what I'm going to do is I'm going to add one more grep. And so I have this whole, and actually there was another grep that I did as well. So there was like a more advanced grep that was actually looking for a more advanced regular expression for filtering the domains a little bit better. So if we go through that, it'll still show us most of the same data. It'll just be a little bit less robust because a lot of the other stuff has been actually filtered out, and then we get to see similar stuff. So we see line bpackaging.xyz. We do get to see files.bpackaging.xyz at some point as well. I've reviewed a lot of the output, but it makes it a little bit, there's less volume, there's less data to sort through. So one other thing that we can do is we can pipe this again to another grep command. And then from this, I could just say grep anything that ends with XYZ, which is, I know that's what the domain name is going to be. So I'm going to do that, and it actually doesn't show me anything. So that's very interesting. So let's see if I can, I actually know that for a fact that it can actually show me that. So I want to see if maybe I did it incorrectly. So let's do it like that. And it still doesn't show me anything. That's interesting. Okay, so let me see, because I know there's a way that I can grep multiple, or I can do like multiple filterings of the data using grep, and I'm just curious as to why this is not working, because I know for a fact that if I go through this data, I know there's a bunch of data, so I want to be able to see if I can filter it a little bit more. So let me, I'm going to fool around with this a little bit and see if I can pull that data for you. Okay, cool. That's what it was. So essentially, I needed to use the regular expressions again instead of trying to filter normally the way that you do. Because really, you could do it in multiple ways. You could actually grep in multiple ways. And the one that I was doing was something like this, where it's like you do grep and then you put the asterisk inside of the quotes to stand for a wildcard character, and then you say XYZ, and then you close it with another quote. And usually, sometimes that actually ends up working, but I think it doesn't work when you're trying to grep through files. I think it would maybe only work when you're trying to grep to find a file name inside of a given location. I think that's kind of what works. When we're trying to grep through the contents of a file, for example, the stuff that's inside of a JSON file, we would need to just further grep using another regular expression. So I used the complicated regular expression for the domain name, and it only yielded these domains for me. And I used the simplified version of the domain search, and then I grepped the again the expression for the .xyz at the very end of the domain to only pull this information. And I actually got a couple of extra domains. So we got the CDN .b packaging, files b packaging, and line b packaging. Notice that obviously we didn't get the HTTP because in this one we were actually looking for HTTP, so it would limit it only to the output that had the HTTP. In this one, it did not limit it to the HTTP, so now we have CDN .b packaging .xyz and files as well as line. But I want to say that the CDN would be command. That's probably what they're trying to do. So command and then files obviously is the files. So let's do cdn.b packaging, like misspelled, and then xyz, and then we will do files.b pack. It's so hard to misspell it, like when you know how it's supposed to be spelled. Okay, cool. There we go. So we actually got the answer. So cdn.p packaging and files.b packaging. So it's useful. It's useful to be able to use cat and go through the information just by looking at it like that. And they give us a few little hints of how to extract values from given fields. But I mean, to be honest with you, there's just too much data. There's like way too much data to not use a tool like grep. It's like you would pull your teeth out if you had to do that. I don't have any hair. I was about to say you'll pull your hair out, but it's like I don't have any hair. So you would pull your teeth out if you had to manually sort through all of this stuff. And like and this is just like the limited output where we actually use the regular expression to try to find only things that have that kind of look like domain names. So imagine if I didn't do this and I was looking at all of the freaking data that was output. It would literally take a long time. I'm not going to say forever, but it would take a very, very long time. So, okay, cool. So we got this answer. That is the very first answer that we got here. Now it says, what is the name of the enumeration tool downloaded by the attacker? And the hint for this is they mistakenly executed the exact tool name. So enumeration tool downloaded by the attacker, and I just know that there's something called GoBuster. I'll do the research for this, but GoBuster is like a really powerful enumeration tool. So is it GoBuster? It's not GoBuster. Okay, cool. So it's not GoBuster. All right, so they accidentally used the exact tool name. So let's try to find that answer. Okay, so first we need to find out what is the PowerShell command that is used to download files from a web server, and typically that is invoke web request. So invoke web request. So let's do it like this, right? So what is the PowerShell command to download a file from a web server? And invoke web request is usually to make any kind of web request from any kind of a URL. And that is most likely going to be the first string that we're going to have to grep for, that we're going to have to search for. And then the second string that we're going to have to search for is the actual domain name, right? So we know that there's the files.bpackaging.xyz domain that was used to download files, most likely, because they're hosting their files over there. So most likely they were able to download the files from over there. So first I'm going to do a grep of just the domain, not the domainer, excuse me, just the actual command of invoke web request. That's the first thing that we'll do a search for. And then from there, we'll see, I mean, most likely, hopefully there will be some kind of a response. But if there isn't, then we'll just go ahead and grep for the domain name itself. So we'll do a case insensitive is what we're going to do for our grep, and then we're going to do invoke web request, which is essentially any query that would be done. And then, so, I mean, it says invoke web request, so it literally has all of these things over here. And let's see, so we have, let me see if I can find any reference to the XYZ domain, although it feels like this seems like the biggest block of text that would be relevant to what we got to do. But it says CDN B packaging XYZ on port 8080. So let's see if I can find anything else. Okay, so the command that actually ended up working was the cat of that without any other exchange or any other parameters fed into JQ. So we just did JQ, although I feel like that's probably not even necessary. And then I did grep -I and then just the domain for the files B packaging website. And so we have 3 different references to it, where there's, script block test. They were not using invoke web request verbatim. So the IWR is a short, kind of like an acronym version of invoke web request. So that's what they were using instead of the actual invoke web request commandlet by itself. And then these are the files that were downloaded. So we have sb.exe and then sq3.exe. And these were the files that were downloaded. Although I think I skipped seems like I skipped a question, because they're looking for the enumeration tool, right? I think that's what the question was. So neither of those are going to be our answer. So it won't be sb.exe. It's also not going to be the sq3.exe, because they're obviously too short of an answer. So what we can do is we can rerun our last command again. And in this particular case, what we can do is grep for the word download. And let's see if that exists. And we have a few. So thankfully, it's actually a short list here. So what do we have? We have from the web client download string, GitHub, secure this shit, PowerSharp, blobmaster, power, invoke seatbelt. Seatbelt might be the name, and then B packaging update. So potentially seatbelt, I think. Seatbelt PS1 could be the name of the tool itself. And so if we now search for this and see if we can find reference to seatbelt, let's see if we can find that. And so he did run seatbelt just by its name, and that would potentially be the thing that he used to run. Okay, cool. So what is the file processed, or what is the file accessed by the attacker using the downloaded sq3.exe binary, and use the full path? So we can do a similar command in this particular case, where instead of searching for seatbelt, we'll just search for sq3.exe and see how many times that shows up. And it shows up a few times. So what do we have? We have 2 references to it. We have this one, where it is the, so it would be essentially right after this, app data, local packages, Microsoft, plum SQLite, and then from there select whatever. So he's using the SQL queries to be able to do something, it seems like. There's another one where there's sq3 out file. That's the one that's being downloaded. So this is the only other one where he's running sq3 and then downloading or referencing this specific path and then following it by print working directory. So local packages, Microsoft sticky notes, local packages, Microsoft sticky notes, local state, plum SQLite, local state. So we have 2 potential answers here. So there, we'll do the first one where it's just local state by itself, and we can use all of the backslashes, so that's great. Local state. Now, local state is not separated by, let me see. So this feels weird. Oh, I see. So I need to do the C dot, and then we can do that maybe? Could that be it? App data. Nope, that's not it. Definitely can't be it. So we need to see if there's anything else that we can pull, but it's very interesting. So let's see what the hint says. The hint says trace back the executed CD commands. Interesting. Okay. The only thing that I can see that would actually be a potential file that was downloaded is this plum SQLite portion. So we need to, and that would be most likely inside of the local state directory. And so if we're referring to the CD commands, we would probably search for local state, I guess. So I can do local state as the first portion of this, and then we can also grep case insensitive, let's say CD. That could be one of the things that we could search for, and nothing comes out of that. So let's just get rid of the CD portion of it and grep the local state, and local state pwd, app data, plum SQLite, etc. So let me see that I feel like this is the file. So like the only thing that would uh, make it kind of complete, I guess, would be where app data would be located inside of the overall machine. So if the user that this was done on, so the compromised user is who? It's Westcott. So if the compromised user is Westcott, right, then we can probably find references to J Westcott and Plum SQLite most likely. So let's see if we can do something like that. So first I can just do Plum SQLite. Let's see what shows up for that. This is the only instance of Plum SQLite that shows up. So let's do a search for is it Westcott or West Scott? I think it's Westcott, right? Let's see. It's Westcott. So for Westcott, let's see what shows up. And okay, so the username is J Westcott. Okay, we're making a little bit of progress here. That JQ command is not making anything nice for us, which is kind of annoying. Okay, so here we go. So this might be a good path here. So we have C users J Westcott. That could be the intro to this. And let's see if there's any other references that I can use that would potentially be useful here. So C users J Westcott. Okay, so we combine a few different searches. The first one is the search for that SQ3 portion that gave us this full path that we have right here, right? So I've also searched for app data because I'm trying to find the full path to the user. So if we actually search for SQ3, if you remember, we just saw this full path, the app data, local packages, which gives us the Plum SQLite, which is most likely because it's been combined with that SQ3 downloaded executable. That's the one that was used to get this file, or that's the file that ultimately we ended up with. The thing that we need to find is the full path, including C, backslash, etc. And so they give us as a hint to look for anything that has to do with CD. And obviously there's a bunch of script block IDs that give us this information. And then there's a few different pieces of information that have to do with the script block text parameter or attribute. And then so we have the CD to the users. So it goes like this, right? So if we go CD C and then CD users and then CD J Prescott or J Westcott, and then from there they were able to go into or launch this piece that they had over here. So if I scroll up a little bit more, we can actually see that we also have this right here, CD app data, etc. So if we combine all of these together, it would be C users, J Westcott, and then app data, etc., etc. So I'm going to take this full thing right here, and we can kind of just manually input the rest of it. So it'll be C dot backslash users backslash J dot Westcott backslash, and then we can paste in the app data portion of it. Or is it not pasting? Let me see if I can paste it. And that should work, right? App data, and everything seems to be fitting perfectly. So let's submit that. Okay, cool. That's it. So yeah, we had to trace a few things. We had to, number one, we were going to trace the actual the file that was accessed using the downloaded SQ3 binary. So we searched by SQ3 first, and then it gives us the path of the file, which is this piece right here, that app data, and then it goes the full path to the Plum SQLite. So that's the full path to the actual file itself that was used, that SQ3 was used to access. And then we just need to be able to find the location of where that whole thing was sitting, and we had to narrow it down by just searching for this CD. And the command for that is very simple: cat PowerShell JQ and then grep for the term CD. And then that's it. That's what we got. And so you just trace it at that point, right? So if somebody's CDing and then printing that working directory, and then they CD to users and then print the working directory, and then they CD to Jay Westcott, print the working directory, and then from there they also there was another CD that went into the app data PWD, which is probably available at some point right there. So music PWD, public PWD, etc., and then app data PWD. So all of these things are actually accessible for us. Documents PWD. So if you trace it piece by piece, you end up getting that final notice, which will end up giving us this full location right here. And then you just combine that with the user's Jay Westcott, and then you add it to the end of it. What is the software that uses the file in Q3? So the software that uses the file in Q3. So now we're going to run for Plum SQLite, I'm guessing. So that'll be the thing that we will search for. So if we just search for SQLite, we can see that, because this is the only thing that actually shows up. So this is the only software that really I recognize. It's Sticky Notes from Microsoft. And that's pretty much it. So I wonder if it's actually Microsoft Sticky Notes. Yeah, well, it fit for the template that they gave us. So it is Microsoft Sticky Notes. And what is the name of the exfiltrated file? And let's see if we can find that information. All right, so here's what I found. The very first thing that I did was I just started searching for Jay Westcott. Now, for whatever reason, even when I use JQ, it doesn't prettify the output. It still kind of gives this jumbled output or whatever. But you just scroll up a little bit. You don't have to go too far. And then you see for the field script block text, there is what seems like a command. So, there's the variable file that's being created that actually has this protected data.kdbx that is turned into this variable, and then the destination location is this IP address, and then the bytes are the system IO read all bytes of this specific file variable. And that very much looks like somebody's trying to transfer something out. It looks like very much a command that's being used to transfer it out. So what I did then, I did the same thing, and I just extracted the script block text field, and then I grepped for Jay Westcott, and then we get this short output. And then so we have script block text, CD, and then ls of this location, and then we have this final value for this field that is officially the command. So it says file documents protected . So that is most definitely the script or the command that is exfiltrating the files. So the question now is, what is the name of the exfiltrated file? And that would be protected data.kdbx. So let's see, protected data.kdbx. Very good. Your answer is incorrect. Please, sure. I mean, what do you mean? That's literally the name of the file. Oh, and I see it's an underscore. So protected underscore data kdbx. Okay, very good. What type of file uses the kdbx file extension? So we could just Google that real quick. I think it's a database though. So it's a KeePass database file. That's what it is. So that one we can kind of, because DB usually, if you have DB in there. Oh, so KeePass. The answer is incorrect. KDBX file. What type of file uses the database file? Or data KDBX, and it is a database. So I mean, I don't understand what would be the other answer. KDBX extension. So let's do a little bit of more researching, I guess. Oh, you know what? It's a password database file. So maybe that's what the answer is. Maybe it's a password file. No, that's not it either. So it's not database. It's not KeePass. Oh, it is KeePass. I just spelled key as in KEY. So it's a KeePass password management file or password database file. Okay, so that's the type of file that uses KDBX. Very cool. What is the encoding used during the exfiltration attempt of this file? So let's go look at the command here. And the encoding would be in here somewhere. So let's see what it is. Okay, so a few different search commands, and finally ended up with the cat PowerShell JSON. We still pulled the script block text field, and then I grepped for the B packaging domain, assuming that that's where the data would be exfiltrated to. And we did see a few different domains, like subdomains as well, at the very beginning of this. And so, we have the CDN location where the command and control whole request is happening, and this entire thing is just one block of text. And then we have another one where they did the update that they pulled, and then we have these two, which were the web request, the invoke web request command that they were downloading the SB and SQ3. And then finally, there's this element right here that shows us, there's a split variable that has the hexadecimal variable inside of it, and that's actually being split. And for each line in split, do this. So hex would be an encoding. So if we're trying to use an encoding hex, there you go. So hex would be the encoding. And what is the tool that's been used for the exfiltration? And in this particular case, we can also see the tool in this final command, and this is an actually tool right there. So NSLOOKUP looks for the DNS records of something. That's literally the only other tool that would actually even exist in this line of code, because everything else from here is not referencing a tool, and this is the only other one apart from the one where he prepares the file. And yeah, NSLOOKUP is the right answer. Apart from the command where he prepares the file, that protected data file, apart from that command, the only other command that would make sense would be the one that is using NSLOOKUP for the exfiltration. So that's pretty much it for the looking at the headers and then the endpoint security. And now we have to look at the network traffic so we can see what else we need to do. Obviously, we got to call the bank, so that seems to be a big deal. So let us finish this whole thing up. All right, based on the log of investigation, we have seen the full impact of the attack. They were able to read and exfiltrate 2 potentially sensitive files. The domains and ports used for the network activity were discovered, including the tool used by the threat actor. And the investigation now is trying to look for the network traffic. So utilize the domain and ports discovered, all commands executed by the attacker and all command outputs were logged, and follow the stream of the notable commands discovered from PowerShell. Based on those logs, we can retrieve the contents of the exfiltrated data by understanding how it was encoded and extracted. So what software is used by the attacker to host its presumed file payload server? What HTTP method is used by the C2 for the output of the commands executed by the attacker? What is the protocol used during the exfiltration activity? What is the password of the exfiltrated file? What is the credit card number stored inside of the exfiltrated file? So those are the last few elements that we need to find. So first and foremost, so it says, what's the software that's used? The hint, it says, review the headers of the HTTP request going into the server hosting malicious files used by the attacker. The headers of the HTTP requests going into the server. So let's go over here. First, we have two big pieces of data that we can mess with. The destination in this block of text, which was the one that was preparing the password file, is this IP address. So that's where it's supposed to be going. And then the destination in this one is the line bpackaging.xyz. So we have those two elements at the very least. Now we have a package capture file that's over here. So I'm going to open that up, and it's going to open up automatically with Wireshark, and we're going to filter through the packets that are available inside of it to see what we can find for the HTTP headers and information. So it says what software is used to host the presumed file payload server. So let's see what we can get. Okay, so the first search query that I have is the HTTP host contains this bpackaging.xyz. There are multiple domains, right? So if you remember, there were multiple subdomains. And the very first packet that we actually see once it's filtered, so there's literally 48,000 packages or packets, excuse me. And then now we have narrowed it down to 932, which is actually not bad. And the very first one that is revealed to us is the files.b packaging XYZ. So let's see if I narrow this down and let's say this equals to files.b packaging. So that's what that query is now going to look like. So our display filter is now files.b, and we only have 3. So excellent. That's amazing. So what's the question that is asking? So it says what software is used to host that file. So we need to look at the headers of this thing. And if I remember correctly, I think if we go to view, it's either under view or analyze, where we can actually see the header. So let me see where that was located. Okay, cool. So it's under analyze. So let me go back. It messed with my filter, and I don't want to lose my previous filter. So it's the files B packaging. And so we'll use that, and it'll go back to this. And if I click on this guy again, and then click on analyze at the top right here, and then we'll go to follow, and then we say follow HTTP stream, and we do that. And then it pulls all of the other packets that were related to this conversation. And so this is what we have. So the HTTP server here is simple HTTP. The software is Python 3, I guess. And that's the only thing that seems to be relevant. And then we have the commands, obviously, that he ran as he was running. So ran as he was running. Python. Okay, so Python is the software. Python is a language, so I can't imagine Python being a software, but I guess Python is the only one that's available because we looked at the header, the HTTP header request going to the server. Okay, cool. So what HTTP method is used by the C2 for the output of the command? So now we can actually look at this information. So we have multiple request headers that we have. So we have the get request, and let me see if I can go back and forth, or we'll just look at the stuff that's going over here. So we have, we did, so what's the hint? It says so we did have a domain name at the very beginning of this, right? So when we found, I don't think it was in part 1, but there was one of the domains that we found where it was actually the domain of the server, the C2 server. It's the CDN B packaging. So let's go and turn this into http.host contains, or it could also equal, but whatever. So we'll do cdn.b b packet. Ugh, the spelling kills me. And there we go. So we have that now. So let's do this here. And so we have get request, and then we have post request. So get request is when you're pulling data from something, and then post request is when you're sending data to something, and we only have get or post request. That's pretty much all of the requests that are being made from here. And the question specifically, the way that it's phrased inside of the question is used by the C2 for the output of the commands executed by the attacker. So it's used by the C2 server for the output of the commands. So if all of these things, let's see, if it's a post request, all of it is the same IP addresses. So there's 1010, all of those things are exactly the same. So if it's being from, I would assume that it's this, yeah, because getting is when you're pulling data from it and you're getting input from it, I would assume. And posting is when you're sending data. So the way that the question is phrased, and the hint really didn't give us anything, and just based on what I understand, post is when you're sending data, get is when you're receiving data, and if the command has been executed by the attacker, the C2 server is sending data. That's really the only logic that I can kind of think of when it comes down to that. So now it says what protocol was used during the exfiltration activity, and the protocol is HTTP. The exfiltration activity. So under the protocol column, we see that everything is TCP. But when you actually go into the packet details, just so you know, there, like as far as transmission of data is concerned, there's literally only 2 general protocols. You could either have transmission control protocol, which is TCP, or you can have user datagram protocol, which is UDP. And transmission control protocol requires a connection to be made. UDP is connectionless, so it doesn't require a specific connection to be made. And for every single conversation that we have, and as far as networking is concerned and understanding what that means for something to have a connection, when you look at stuff like that, for the most part, everything is going to be TCP or UDP, basically. And if you want to learn more about this, you can just go look at the Network Plus playlist that's available. So I would presume that this would be a TCP protocol. And that's interesting so it's neither TCP nor UDP. That's interesting to me. So that is something that I'm very, very interested in to see what the potential answer of this would be, because that's so silly. How's that not even? So let me see. Okay, so there's actually something else, I guess. So there's the DNS protocol, the domain name system, domain name service, and this is the hint right here. So the NS lookup tool was the tool that was used for the exfiltration, if you remember from our last segment. So NS lookup deals with DNS, so the domain name service, the domain name system. And if they're using this block of code to send the data, to exfiltrate the data to the line B packaging website, and they're using NS lookup, that means they're using the DNS protocol. So that is the answer for this one. Now it says, what is the password of the exfiltrated file? It's stored in the database file accessed by the attacker using SQ3 exe binary. So let's see how, there is usually a way that you can extract the objects that are attached to a packet capture file. So if we go to file and see if we can export objects, there we go. And then we're gonna try to export the HTTP objects. There is a lot of HTTP there is a lot of HTTP objects. And we're specifically looking for a file itself, the file itself. So let me see if I can actually find the file name that we're interested in. Okay, so there was nothing here for my system seems to have frozen. There's nothing here for the name of the file that was extracted. And there was nothing here for the KDBX, which is the extension of the file. So none of those things, unfortunately, exist inside of our exported object. So another way that we could do this is we can use the name of the software that was used to exfiltrate the file. So if you remember the executable name, so if we go back over here, we may be able to see the executable name that was used to extract it. And so we see right here, so SQ3, and then you have the potential, hold on, let me see. There's also, it was used earlier on as well when it was trying to extract the database file, that plum something, whatever it was. So SQ3 was the name of the file specifically that was used to extract the document. So let's see if we can actually find something that contains SQ, or let me put it in here. So SQ3.exe. Let's see if that exists at all. And it does. It actually does exist. So we have get SQ3.exe, which is something that I believe they used to download the file that we were looking for. And then we're trying to find something that has to do with the data transfer. So there's literally only 4 files. So or 4 packets, excuse me. I'm gonna go through the data of these things to see which one would be of interest to us. And one of the hints is usually the ones that are later in the timeline would have to do with the data that was exfiltrated. So if we look at the last one, presumably that would be the one that actually has to do with the data that was exfiltrated from what we're looking for. So you actually can see it right here as well. This was the original command, right? So music, SQ3, and then app, data, local packages, Microsoft, sticky notes, and then local state, plum, SQLite. You see that, right? So that's probably the packet itself. So let's see what we can find when we now analyze this packet by following the HTTP stream for it. So this is the one that is actually making the request from the SQL database. So you see that there's a select everything from the note and then limit 100. So this is the original request that's happening, and this is the very first packet that we saw. And so this is the TCP stream of 749. So this is what you can see that has been changed over here. So TCP stream 749 is what yielded that packet for us. So ideally, the next one in that stream would be 750. And so that should bring up this interaction for us. And if we go ahead and look at, let me see, this is the one that's highlighted. So if we go ahead and analyze this thing, let's see if we can actually get any data from this one. The data of this one, and it is actually coming from the CDN packaging website, so that's good. And it is a post request, meaning that it's actually giving us some of the information that we're potentially looking for here. So from here, this is the data that's been encoded that we need to decode. This is not base64 encoding. If you recognize what we saw with base64, this is very, very different. So we're going to highlight this. We're going to copy this. We're going to go to CyberChef, and I'm going to delete this portion right there. And I'll go ahead and paste the stuff that we found. And now we use this magic wand to give us the information, and it is a decimal encoded. So this is decimal encoding. And now we actually get to see the data here. So master password, that's the password that's been extracted. So now from here, we should be able to actually see the password. And this, of course, is for the J. Westcott user that's making this request. So now we just need the password. The way that this seems to be separated is through these backslashes that we have here. So this first ID is the master password. The next ID looks like this might actually be the password. And then separated by this pipe, and it goes to manage position. So that seems to be the password. And it is a pretty complex password, so I'll give it to him for having that. So let's see. Is that the answer? Cool. Okay, that is the answer. Nice. That was cool. All right, that was a cool little experiment to be able to gather that information. Nice. All right, so I think we have literally one more question to finish this exercise. Yeah, so where's the credit card number stored inside the exfiltrated file? And retrieve the exfiltrated files using T-Shark and focus on the query type used in the PowerShell logs. So retrieve the exfiltrated file using T-Shark. So I gotta dust off my knowledge when it comes down to T-Shark. It's been a minute since I've used it. It is a command line tool. I know that much. So I'm gonna go to my terminal. I'm actually gonna keep this one open because it has a lot of the history of the data that we have. So I'll open up a new terminal, and we're going to go to our desktop artifacts location. And now we're supposed to look at the capture file. So we're gonna do T-Shark and then R to read the capture file. And so let me zoom in on this a little bit for you. I'll drag it over here so it's easy for me to go back and forth between my two windows, because I really do need to look for the command that extracts data using T-Shark. So it is capture.pcap. That is the information. And now we are going to look for a field. I need to pull up my notes. I don't remember how to craft this command. So give me a quick second. Okay, the first command that I ran was just reading the pcap file using T-Shark, and then the Y that you see right here is helping us to extract certain fields from it. So -Y is a display filter, essentially. So when you do the -Y and you use the display filter, now you have to give it the display filters that you want to customize by it. And this is no different from putting these fields inside of Wireshark. So dns.query.name is actually a field or an attribute that you can filter by. So we're going to do dns.query.name matches the bpackaging xyz. So this is a regular expression that would be used. And so we do 2 ampersands to include that we also want the destination to also be the IP address that we found earlier when they were doing the exfiltration, when they had started the exfiltration. So when we run this, we get these series of requests, or these responses, excuse me. And so we see bpackaging xyz, and then we also see there's bpackaging xyz and then .eu west, and then it's going to Amazon AWS. So probably we want to remove all of the ones that have to do with this, the EU West, the Europe West region of Amazon, because this is just the Amazon domain, and it doesn't have anything to do, or not that it doesn't have anything to do, but I don't think this is where the exfiltrated data would be at. I think this is just maybe a proxy server that they're using potentially, or it's like the in-between server. So what we want to do is we want to remove that piece from it. And I should probably also just extract a specific field in here, because there is other data that's being extracted for us as well. So I want that specific field that I would be most interested in. The capital T, I believe, is the command that would go ahead and pull a given field for us. So we will do, let's see how that breaks down. It would be capital T, and then we give it the field name, and then we're extracting a specific fields, and then we're extracting, so we'll do -E to extract it, and then we want to extract the DNS query name one. So if I do that, it should give me, yeah, okay, it's a little bit of a cleaner output. So we still do see the EU West one, and then we see the B packaging just by itself. So we will run that same command one more time. Now we're going to grep the inverse of something. So when you do grep and you want to show anything that does not include a specific field or a specific value, technically you do V. So it's basically going to look for whatever I tell it right now, and then it's going to show me everything that does not include that in it. So it would be EU West, right? And that should only show me the stuff. There we go. So this only shows me the stuff that does not have EU West in it. So we're getting a little bit better of a filtering here. So we need to now essentially try to find a way to pull the information that we need. We need to pull that data that we need out of these packets, which is, there's a good amount of stuff that's going on here. So there needs to be something that hopefully we can craft together to extract the data. So this, I'm gonna step away from, I'm gonna cut it, so you're literally gonna see like me with the answer, but I need to do a little bit of homework here to see how I can go ahead and pull that information from it. Okay, the one thing that we can first conclude is that this is where the data is. All of this stuff that you see right here, this is actually where the data is that we need to extract from these specific queries and from these interactions that are happening with B Packaging's website. So what we need to do is we need to remove all of these and just only extract these. Now, at the beginning of this video, at the beginning of this room, they said that we need to learn, or we need to use the tool SED, S-E-D. And SED is actually used to replace the content with another bit of content. So there's a specific formatting that is done to do it. And the formatting itself is essentially this. So let me kind of zoom in so you can actually see what's going on. So the formatting is like, so you do, S and then /, and then there is the old data or the old value, and then you want to replace it with the new value, and then you do G at the end of it. So it would be SED, and then you would put something like this in the middle. So this is kind of the full command of what it looks like. So it would be SED, and then you would do S dash, and then the old value / the new value, and then you would do G, and then you would close it off. So in this case, the old value for us is going to be the .b packaging XYZ. This is the old value, right? And then what we want to do is now we want to replace that old value with basically nothing, right? So technically, so let's actually run like a test version of this so you can kind of see what this looks like. So we'll run the same last command that we had that removed grep EUS, and then we'll do sed, and then we'll do S, and then I'll do .b pack. The spelling, bro, the spelling is like what kills me. And I'm gonna do /, and then just for the hell of it, I'll do new, and then we'll do G at the end of that, and then we'll press enter, and then it's gonna essentially just replace everything. And I mean, it didn't do it, so that's kind of, well, that's so annoying that it didn't do it. I think I may have maybe mistyped it or something like that, but it should do it. So that's the thing that I need to verify to make sure that the value is potentially right. And maybe it's because I used the word new as an example. Maybe that's why it didn't work. So let's run that one more time. I'm going to try to see if I can actually make this work. Oh, I see. So it's because the reason I actually misspelled packaging. So there's an A missing. So let's try that one more time and see if that actually works. Okay, cool. So see, now it actually added new at the end of it. So it's because I literally misspelled B packaging because the freaking spelling of it is so annoying. Okay. All right, so now we know that we can essentially search for a given value and then replace it with a new value. And in this case, we replaced it just with the word new. So what we want to do is we want to replace it with nothing. So we want it to just give us the values themselves. So if I do this, then it'll just display all of the values. And there we go. This is all of the stuff that was followed by that .b packaging XYZ. So now we just want to output this so that we can create some kind of a script to essentially just kind of parse through all of these values and see if there's a way that we can extract the data. The type of file, or I'll just do raw data, and then we'll have a binary extension to the data. The reason for this is because we want it to be raw. We don't want to have any kind of potential confusion later on as we try to process through this. And I mean, it really, at this point, it kind of doesn't really make that big of a difference on what we extract this data to, because it's essentially just going to read this line by line. So that part isn't really that big of a deal. But it might be a little bit more convenient later on if for whatever strategy I have to use to try to now extract the data from this, which is actually out of my depth. So I do need to try to find some information to see how I can go ahead and extract this data or extract the values from this data, and we can hopefully do it successful. Okay, so the very first thing that I need to do is figure out what kind of data that we're looking at, and it is hexadecimal characters, and we don't need to, I mean, if you want to know what hexadecimal is, you can always go ahead and read up on it, but I need to know what type of character it is so that I can go ahead and try to decode it somehow. And one of the things that specifically we were talking about earlier inside of the exercise is the type of file that we're dealing with, right? And so if we go ahead and remind ourselves real quick what type of password file they had downloaded, it was the KDBX password file, and it was using the KeePass software to actually read it uses KeePass, and you would need to use KeePass also to go ahead and use it. And it actually also, we were given the exfiltration of hexadecimal anyways, so we also have hexadecimal in that answer as well. So there's a few different hints that we've already gathered, and one of them is that it's hexadecimal data. The other one is that the original password file, the protected data file, was a KDBX data file that was protected, and then we have the password as well that we got for that. So we need to essentially reconvert this data from this hexadecimal format back into KDBX essentially, and then from there we would open it up with a tool that can read KeePass or that KDBX extension, and hopefully it'll actually have the data that we're looking for. So this is our raw data binary file, and I'm going to close this out here, and we need to create a basic script that would just convert it for us. So I'm going to clear this portion right here. I will do nano, and I know, so let's see, what would be a good tool that can convert hexadecimal into KDBX or at the very least decode hexadecimal for us. So let's see. Okay, cool. So we can use the bin ASCII data, or the bin ASCII module kind of library that's available for Python, and to be able to convert the data that we have from hexadecimal to something that would be KDBX, which is the KeePass database. So bin ASCII is actually a module that should be available kind of like by default. We shouldn't have to download it in any way. So let me see. I'm going to do like converter .py. So we'll create a converter.py file. We're going to do the shebang bin, and I actually need to know where the Python file is, or where the Python interpreter is. So let me see if I can I need to be able to locate my Python interpreter. Okay, so I have Python 3 installed, and I need to see where Python 3 is located. So it's user bin Python 3. So it's in my user binary location. So that would be the location of my shebang file. So do I still have my converter? No, I don't. So nano converter.py, and then it would be shebang, and then we would do user bin Python 3. That's where it is. Okay, so now from here we need to actually import the bin ASCII library, the bin ASCII module, and then write the script that would hopefully go ahead and convert that data for me. So I completely forgot what the name of my file was. That is the raw data.binary. So that's the name of the file. And now we can hopefully hopefully I'll be able to write a decent script that would make it work. Okay, I want to say that that's it. I can't imagine that. This is a very, very simple script. We have the input file variable, which is going to be the raw data.binary, and the output file, which is the data kdbx. So these are the two variables that we've created. We imported the bin ASCII or bin ASCII module, and then so we're going to open the input file in read mode as the input variable, and then we're also going to open the output file in write mode as the output variable. And then for each line in the input file, we are going to strip that line of its spaces or anything that would be available. So we're just going to take that specific line, and then we're going to use bin ASCII. So this is where the bulk of the work is being done, basically. The bin ASCII unhexlify. I think that's how you write it. I have to verify this. We'll run it. We'll see if it actually works. And then the output file is going to write the binary data, which is going to be each line that has been decoded. So let me just make sure that this is actually right. Hopefully it is. And then we'll run the code, and we'll see how it works. All right, so I have confirmed that this is the right script, the right formatting of the script. And yeah, so the main reason why we want to have this in binary is so that this actually can be converted into a kdbx file. We are writing in binary mode, and everything else has been right. So this reference right here for bin ASCII unhexlify is also correct. So we're now going to write that, close that, and cross our fingers. And let's see if we can actually get this file to work. So we're going to use the converter.py, and it's going to run. And now let's see if we have a data.kdbx, which we do. And now we got to see if we can actually open this freaking thing. I don't know if KeePass is actually even installed, or how I would even read KeePass. So let's see if we have KeePass over here. Okay, so I just found out that this virtual machine is not connected to the internet, and I cannot download KeePass on here. And to be honest with you, I was not able to find KeePass installed. Oh, I'm so blind, bro. It's literally, I was just about to like copy this on my computer and go ahead and freaking do all of these things to transfer this raw data on my own computer and download KeePass on my own computer and run it. But apparently I can't see or something, and I completely missed this freaking file, missed this software. So we are going to now run the file inside of KeePass, and hopefully it'll work. So we're gonna open the file. I feel so silly right now. You don't even understand. Desktop artifacts, and then data kdbx. There it is, and we're gonna open it. It's gonna ask us for the password. Okay, great. So let's go and grab that password that we had over here, which is this whole thing. So we're gonna copy that, go there, and we're gonna paste that. And okay, company card, look at that, we got the company card. So we click on that, and we have the information. Oh my gosh, this feels really satisfying, yo. This feels so freaking satisfying to actually be able to pull this information. So how do I copy that now? Company card, there we go, properties. data account number. There we go. Edit the account number, grab the account number, copy it, go over here. This is it. This is it. Yes, excellent. So this was a nice challenge. I really enjoyed this. It taught me things, and I got a chance to flex my muscles a little bit and practice the skills that I needed to. And there's only a few other rooms that are left in the SOC level 2 or SOC level 1 path for these practical exercises. So as a review for everything that we did, right? So let's zoom back in this. Let me just close everything out so we can kind of move on. I'm so excited that I got a chance to actually even finish this. This was very, very satisfying for me. So what do we have as a review? We obviously just reviewed everything at the beginning. They told us what we needed, and then we went into the email analysis part, and this was very, very easy to do. Most of this information was readily available by just looking at the email itself. So this is the person that emailed her. This is Julianne Westcott, the person that got the email. We had to look at the headers, and we did that by just looking at the email source. So when you open it up inside of the Thunderbird application, you can just look at the source of the email, and then you just search for DKIM signature, and there were 2 segments, and the second one had elastic email in it. And then the name of the file that was inside of the encrypted attachment. So we just had to download the zip file and then not unzip it. Yeah, unzip. Yeah, we had to unzip it. We had to extract the data from it. And from there, we got the LNK file. And then inside of the email itself, they gave us the password. And then we all we literally had to do was just run this link parse, and to get the link file, which is this thing. So you run link parse, give it the name of the link file, and then it'll give you the command line encoded payload, which was just this little long piece of base 64 encoding. So that was that segment. And then to look at, this was a little bit of a heavier part. I think this was the part that took me the most amount of time to go through, and we had to use the PowerShell JSON file as well as JQ to kind of prettify it and then extract some data from it. And so the very first one was the extraction of the domains, right? So first it was the inside of this, they didn't really give us anything except just this piece. And this is what you'll find in incident response, is that the information that you gather kind of stacks on top of each other. So this was the first key piece of information that we gathered that stacked, that was used throughout the rest of this investigation. So if you go through the commands, right, you do cat and then PowerShell JSON and then JQ and then grep for the B packaging XYZ. And that's how we got these various domains that were available to us. And then we got CDN, which was for the command and control, and then files, which is what they used for their file server. The name of the enumeration tool that was done by the attacker was, again, available by simply just going through the web requests. And they didn't do the invoke web requests written out. They did IWR. So that was the one thing that was useful to be able to find that information. And then getting the path of the file, that was the one that kind of was a little bit difficult for me. And so we searched for the sq3.exe first, and then from there we found this portion of it. We found the app data and everything like that with the Plum SQLite. And then the hint that they gave us was to trace back the CD command. So the next thing that we did was we grepped for just the term CD. And then from there, we were able to find the fact that, he first went into the C location, then he went into the users, and ultimately he went into J Westcott. And then if you combine all of that, you get this full path. And then inside of this, you also get to see that he used Microsoft Sticky Notes. Microsoft Sticky Notes was the software that he used to read the file. And then the name of the exfiltrated file, which was, this was a little bit also a bit of a mission for me to try to find. And for that, I want to try to recall the information that I did. But I think for the exfiltrated file was, I was looking for the name of the website that they use. So the B package XYZ, as well as the extension of it, which was the files.bpackage.xyz, and then there were just a few different extensions as well that we searched. So the what's her name, Westcott. We looked for Jay Westcott, and there were a few different, and you can literally go and look at all of the details of this because I outline every single one of these things. So I'm just doing like a review right here. But we found a KDBX file that he was exporting. We found out that KDBX is a KeyPass file. We found out that it's encoded in hexadecimal. And then the final tool that he used for the exfiltration was NSLOOKUP. And then we looked at the headers of the packet inside of the Wireshark, and we looked for, again, B packaging or B package XYZ, B packaging XYZ. And then we found that the very first one was the Python. So we just looked at the headers of it, and that was it, the HTTP header. And we narrowed it down for the C2 server, which is the cdn.bpackaging.xyz. And then when we looked at that, we saw that there were only either get or post headers. And then when you're looking at output, so the C2 used the output of the command. So that's usually when you send data. And when you send data, you're using the post request. The DNS protocol was used because he used NSLOOKUP to do the transfer. So he was using DNS protocol. The password of the exfiltrated file was an interesting one. So we had to trace the conversation. We had to trace originally when we found the very first one that was being done to their files.bpackaging.xyz. When we looked for that domain, the very first one was the initial command that was actually sending the data to it or requesting to send the data. And then the second one, the second sequence was 750. I remember that part. That was the one that had the reply. And then we had to just decode that reply. So we used CyberChef to decode that reply, and we got the actual password. And then finally, this was the piece right here. And this was the piece that we had to use T-Shark and then that whole lengthy command. And that was also something that I had to knock off the dust or clean off the dust in my T-Shark skills to be able to pull that data. And then we were able to extract the data and kind of filter down the data. And then we used sed to replace that .bpackaging.xyz with nothing so that we can just fully extract that into raw binary. And then we use the binary ASCII module Python library to go ahead and convert that into proper KDBX, the proper KDBX format. And then we used KeyPass to open it. And that part was super satisfying. So that was the whole run through. This was very, 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 very cool freaking exercise. I absolutely very much love this exercise. I feel great right now. I'm on a great rush because I feel like I learned a lot from this. So that's great. I hope you were following along with this as well, and I hope you got a lot of value out of it and you were able to accomplish everything that we accomplished, and hopefully you understood what was happening. Hopefully you kind of understood the logic behind everything that we did to get the results and the responses that we got. To get more videos like this one and to get updates in the future about everything that comes out of this channel, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. If you have any questions about what went on today, please drop it in the comment section. I totally do understand that this was more of the complex strategies that we've done, and it was more of a complex room compared to everything else that's happened. So unless you've gone through the basics of cybersecurity with CySec 101, and unless you've gone through all of the introductory videos that were inside of the SOC Level 1 playlist, which this is technically a part of, unless you've gone through all of that stuff, you're going to have a hard time to understand what just happened in this video. So you will probably have questions and you will probably need to ask whatever it is. So I respond to all of the questions, but I will most likely refer you to, hey, go watch this video. If you haven't seen that video, you need to go watch that video so that all of this ends up making sense for you. But drop a comment. I always welcome comments. I always respond to all the comments that come in. And of course, go check out whatever videos are available here that would be relevant to what you're needing or what the information is that you would be needing. Everything is in great detail, so you'll get a lot of information out of it. And of course, like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, because there's a lot of stuff that's going to be coming out very, very quickly, very soon. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video later.